Okay, great. So I'm going to take you through kind of a 5-part lecture. It's kind of summarized from kind of the tertiary lectures I give at the University of Johannesburg. And the first part, we're going to look at kind of the global trends around sustainability. We'll talk about like what does that mean for South Africa and Southern Africa. What are the tools that are used to measure sustainability internationally? And then we'll go through kind of practical examples both at a city scale and at a building scale in terms of kind of technology. And you'll see throughout the presentation, I've tried to give as much practical advice to homeowners like yourselves, or if you've got commercial businesses about, what does sustainability really mean and where is it going in the next 20 years? So that's the plan. Are we good? Yeah. Okay. A bit of background about myself. I studied at the University of Johannesburg in architecture. The first practice I worked at was a practice called Mashibane Rose Associates. And they do a lot of kind of heritage museum work. So I was involved in kind of theatre design, museum design, public transport design, quite broad. And then since our founding, which about 7 years ago, we've been involved in some of the kind of firsts for South Africa in terms of net zero, which I'll give you definitions for now. But it's really about not doing any bad. So a lot of the green building ratings are about doing less bad, switching from your diesel to petrol, less bad, rather than like fully electric. And net zero is quite a nice thing to explain to clients because it's simply a mathematical equation that everything you're generating, everything you're consuming is off a renewable source of energy. Really, that's what net zero means. So I will go through some of these projects today just so you see exactly how sustainability can be applied in Africa. So where does sustainability come from? Why is it such a big deal for us at the moment? So over the last 50 years, we've started to really understand the way in which the planet works. This is work done by Stockholm University, and it's really understanding that the planet has these 9 what are called planetary ceilings that we need to live within for the planet to be functional. So some of these might be kind of confusing, don't worry. Novel entities is just pollution. There's a lot about the atmosphere and the ozone layer, ocean acidification, PMN, that's just kind of potassium and nitrates from over-fertilization in our agricultural space that gets into the ocean and does a whole lot of terrible things. Freshwater use, we're kind of familiar with that in terms of living in Africa. Water is quite a precious resource. Land system change. Biodiversity is a big thing in terms of understanding that system and how it works and how kind of destroyed it's been over the last 50 years. And climate change is a big one. So you can see everything in red are things that we kind of outside the safe operating space. And we need to kind of reverse that kind of, the impact we're having on the environment. I'm sure many have seen these things. SDGs and ESG reporting are becoming very important in kind of, the big commercial entities across the world. This is the UN's 17 development goals, all about kind of lifting people out of very tough circumstances around the world. And so you're seeing these kind of 2 models come together, both the planetary ceilings, which is this outside model, as well as building kind of social foundations. We can't be solving environmental problems and ignoring social problems. We're pretty familiar with that in Africa. So just understanding the relationship between carbon emissions, carbon dioxide, and climate change, there's a direct relationship to that. It's really an indisputable scientific fact now that we are responsible for the warming of the planet at the moment. And so there's a different kind of curve compared to COVID that we need to start bending, kind of within this 1.5 degree warming, which is what we as a country have signed in terms of the Paris Agreement, between 1.5 and 2 degrees. And then there's a term called drawdown, which is when we're starting to bend the curve and starting to kind of release less emissions into the atmosphere and starting to bend that curve downwards towards zero. So that's the goal for the world to do in the next kind of 20 years. Just to understand the sources of the carbon emissions, this is most of the major industries. What's interesting is if you had to combine, obviously, the energy we use within buildings, electricity, as well as kind of the materials we build, glass, aluminium, concrete, 30 to 40% of CO2 is produced by the building industry itself. So a massive amount of the carbon emissions we produce is from the building industry. That then obviously gets released into the atmosphere. About 60% of that remains in the atmosphere, and then the rest is absorbed through sinks. So you've got land sinks that absorb forests, grasslands, wetlands, absorb carbon dioxide and store that. And then you also have ocean sinks that absorb carbon dioxide. So the idea around this is to reduce our sources, pretty simple, support our sinks, and improve society. We've seen that as we've lifted people out of poverty, they produce less carbon emissions. So those are kind of the 3 overall goals for us as a civilization. These are the major industries. I won't go into detail about this, but if you're interested, this is kind of the effect that each industry would have in terms of its carbon emissions and how we can reduce those things specifically. Part 2, what does that mean for us in Southern Africa? So we're looking at about, if we don't do anything, we're looking at about a 4 to 5 degree average temperature increase. That's this kind of dark area around Angola, Botswana, which are already dry places already. And about 40 to 80 millimeter rainfall reduction across kind of the Tanzania, the middle of Congo, and remember that's our kind of high forested area that's already absorbing carbon. So this is important to understand this is obviously over a year annual period. This doesn't take into effect the extreme weather events that we're already starting to see across Africa. And you can imagine most of these people are subsistence farmers. So what does that mean for food security? There's a strong link between how the climate is changing and how people are getting forced out of their countries because of climate-related risk. The clearest way I get to explain this to South Africans, because 1 or 2 degrees might not mean much, that's a little bit hotter, so what, is to try and show how our landscapes are changing in South Africa. So these are our major biomes. The big yellow area is grassland. We've got savanna in the north, Kalahari, the Karoo, the Cape. And what we're seeing is a reduction of our grassland area basically just around Lesotho by 2050. You're seeing the Kalahari spread into that area as kind of a dry savanna. And you're seeing desert, kind of the major desert of Namibia moving into the Karoo quite extensively. So this obviously has problems for us as biodiversity, but also most of our kind of the breadbasket of South Africa is the grassland biome. And what does that mean also for us in terms of food security? So what a lot of the R&D and what we do as a practice is get out into these rural areas, study these ecological systems, learn from rural people which have been living sustainably most of the time for centuries, and unpacking what is a sustainable way of living in an African sense. So we've traveled from the Namib Desert, the Okavango Delta in Botswana, and you'll see a lot of this work, how that translates into our building designs. So you're seeing a move from a grassland landscape, as I've mentioned, to a dry savanna, and the Karoo's moving to kind of a hardcore desert. And the excitement around this is, again, sustainability, specifically in the European or the Western sense, is about these new technologies. Where for Africa and Africans, the understanding about sustainability is really just remembering what we've done for thousands of years. So a lot of this knowledge is already there that we can translate now in a contemporary way. So this is an interesting example. This is a rural village in Wakkerstroom in the Free State. And there's no kind of formal gazetted nature reserve around this area. They're cattle farmers. And because they graze the land, this specific endangered type of bird, which is only found here nowhere else in the world, you get a whole lot of people coming from all over the world to see this bird, because the landscaping is still maintained in a way that it has been for thousands of years. So this is important to, a lot of these projects are, kind of illustrating this kind of informal way of conserving land that still is very sustainable. This is quite interesting. So we've got a very high diversity of succulents in South Africa. Some 70 to 80% of our succulents are found nowhere else in the world. And so how do we translate these ideas around this plant? So if you think about this as a building, it's basically got a skylight at the top. It's solar panels, chloroplasts on the inside of the plant. So putting the solar panels on the inside with the skylight at the top. That's kind of an architectural idea waiting to be translated. So us as a country, what are our major greenhouse gas emissions? So the major greenhouse gas is carbon dioxide. There's some methane and nitrous oxide from obviously farming and our industry, but the major one is carbon dioxide, and most of that is within how Eskom makes its electricity. But remember, again, that 40% idea. 40% of that energy is used within the building. So if you're having efficient buildings, you're already having a downstream effect on your carbon emissions. And then this is an interesting graph. Everything below the line in blue is absorbing carbon dioxide, large-scale land sinks within South Africa. This is mainly our commercial forestry. It's absorbing a lot of carbon. And you can see kind of grasslands, which is that light gray on the right-hand side, or left-hand side, your right-hand side, is also absorbing carbon. And interestingly, our most threatened biomes throughout the country are the biomes that give us the greatest potential for absorbing carbon. So as we conserve and rewild and regenerate ecological systems, we also get kind of carbon emissions. This is our whole company on one slide, really defining what sustainability is, our major goals as a company. We're kind of a low profit, high impact company, linking into everything that I've spoken about. So I won't read this to you. If you're interested in it, I can chat more about it. But let's get it down to an individual level. We've done a lot of work with individuals, just trying to kind of audit their carbon footprint. What can I do better? And really ask the question, why is it so difficult for us to be sustainable? And this is probably the most effective way we've come up in presenting that. So on the left-hand side, you've got middle-class South Africans that we've done audits on in terms of their carbon footprint. Most of it is in the electricity usage that we use in terms of being connected to the Eskom grid. And the other is on transport. We don't generally, as the middle class, use public transport. We've got private cars that kind of, one person is in it versus kind of the European model. And you'll see a lot of discussions around sustainability being about, food, plant-rich diets, and that's all fantastic. But that isn't necessarily applicable to us in South Africa, where our methane production is very, very small. Most of our grass-fed beef is free range already. So it's important to understand specifically where your carbon footprint is as a family. And on the right-hand side, these were the 5 categories that we audited versus their percentage of personal income spent in each of those personal categories. So the idea is that where we need to save in terms of greenhouse gases, we're not spending money on our personal income. And that's really why the shift hasn't happened. Our electricity relatively is still quite cheap. Our water is relatively quite cheap. You can see most of our money in terms of those 5 categories is spent on food. So, the starting point in terms of, speaking about organic gardens, starting your own vegetable gardens, that's kind of a starting point for you. But that's not really having an impact when it comes to your carbon footprint. Okay, so how do we measure these things? This is important. Sustainability has become kind of a buzzword. A lot of corporates have kind of latched onto it and used it as what some people call greenwashing, kind of as a marketing campaign rather than any kind of in-depth change. These 2 big dates are important. And I'll get into definitions around what specifically net zero means, but just keep net zero in the back of your mind. So the World Green Building Council wants all new buildings to operate at net zero carbon by 2030. Our major cities have signed onto this. So if you're building any kind of new building after 2030, it will have to operate at net zero carbon. And then they want all buildings, new and existing, to operate at net zero carbon by 2050, which is a much scarier target for me in the built environment, because that would mean things like informal settlements. Every single building would have to operate at net zero carbon, which is huge. But our cities have ratified this into law. So you'll see policy change around your buildings plan submissions when it comes to kind of energy disclosures. This is just for people that are interested in green building rating systems. There's like thousands of them all over the world. Each country has its own. So what I've tried to do is put on one slide kind of where they sit together, the major well-known ones. So if you think about this line being net zero, meaning like you're not having any environmental impact, everything below the line is this kind of less bad. We're trying to be better, but we're not really net zero yet. Everything above the line is when we're having a positive impact on the environment. So in the bottom left-hand side, you have EDGE. This is funded by the World Bank, IFC. So this is mainly for residential. It's kind of your easiest sustainability rating. But you do get bond reductions from the bank. So I'm sure you've seen Baldwin, or you might not have seen, they've got this green bond, whatever they call it. That's the EDGE rating. You'll get a couple of points off your interest rate on your bond. EWP is your existing building rating from the Green Building Council. Green Star is our new building rating system from the Green Building Council, mainly kind of commercial buildings, large-scale commercial buildings. You can do residential, but it's expensive rating. We borrowed that system from the Australians and rewrote it for our context. LEED is the American system, probably the most well-known in the world when it comes to green building rating systems. The net zero rating system, which I'll go through a bit later. And then you've got other ratings that talk about restoration. So the World Green Building Standard is around human health. It's got peer-reviewed research on how buildings affect human health. And you can basically, hospitals, think about anything that's around human health can be rated on that. The Living Building Challenge is the most difficult rating internationally to do. Again, I won't go into too much detail, but a very, very difficult rating. We've had one one project in South Africa do it at a petals level, which is kind of a couple of categories, not the full one yet. So we don't have an African example yet of the Living Building Challenge. This is some of the policy change that's happening just for you also as landowners. This doesn't really apply to residential, more for commercial, but if you do have an office or work as part of a company, this is important to know for you in terms of policy change. So what we're seeing is gazetted in law now is by December 2025, you're going to have an EPC for large-scale commercial buildings. So that's the kind of that star rating you see on your fridge and your washing machine. That says A, B, C, how sustainable I am. You're going to have that for buildings now. So that's important to know in terms of if you are part of a large-scale building. And then you're seeing basically the SANS 10400, which is your XA, which is your energy standards for buildings, starting to reduce how much energy you're allowed to use within a building. And that's how they're going to move you towards net zero. So originally it was 200. You can see how that standard now has dropped to make buildings a lot more efficient in terms of their design. And then I've spoken about the cities ratifying that net zero carbon specifically will be law by 2030 for new buildings and 2050 by existing buildings. So these are some of the buildings that we've done that have been officially rated as net zero. So there's 4 categories of net zero. You get net zero carbon around carbon emissions. You get net zero water. You get net zero waste, and you get net zero ecology. South Africa is the only green building council in the world that does more than carbon. If you think about politicians when they speak about net zero, they're just thinking about carbon. So we probably have the most progressive net zero program in the world, which is really exciting. The Flayhaste development I'll go through in a little bit more detail. There was triple net zero, so most clients just aim for one. We got 3 of those ratings for one design. The ISA standardized clinic is government's first net zero carbon operational building that we designed. And then House Baldwin Ruggivan was the first net positive waste, construction waste project for South Africa. So these are the definitions. If this is all you remember from the presentation, I would have done my job. Net zero carbon is different to terms like carbon neutrality. So carbon neutrality is speaking about just basically offsetting your current consumption. You're not really doing anything in-house as a company. You're just offsetting everything with some kind of renewable source. Net zero is different where it talks about efficiency first. So you first try and reduce your consumption as much as possible. So practically in a building, LED lighting, insulation, kind of that stuff that's pretty common knowledge now, to make sure that your consumption is as small as possible before you kind of look at a renewable energy technology to offset that consumption. Does that make sense? Highly energy efficient, and the remaining source is on renewable energy. Sometimes on-site, we prefer on-site first, embedded PV on your roof or wind or whatever. But there's also an opportunity for off-site kind of linking too. We're seeing feedbacks into the grid now. All those policies are in place for our major cities. And this is measured over a year period. Net positive is when you're generating 5% more than you need. And that is either fed back into the grid, fed to your neighbor, used as some kind of resource. So this is when you're starting to actually make a positive impact, not just a net negative impact on carbon specifically. Ecology, net zero ecology is for greenfield sites, so sites that really haven't been influenced that much by humans yet. Net positive ecology is where you're doing a brownfield site, something that has been kind of renovated or destroyed, and you're bringing back the original system. I spoke about the Living Building Challenge. You have to have net positive water and carbon for the Living Building Challenge, as well as kind of regenerating the site's existing ecology. Water is the same concept as carbon. So you are taking a renewable source of water, something like rainwater, or treating grey water or black water and reusing that. Again, efficiency first. So low flow fittings, you can't flush your toilet with 7 liters of drinking water, it doesn't make sense. That kind of thinking around treating water as a precious resource. Net positive is the same idea, 5% more than what you're consuming. Net zero waste, again, everything is recycled, recovered as much as you can. That's your efficiency, and then nothing goes to landfill. Not one piece of packaging, not one sweetie paper, nothing goes to landfill. And this was quite radical for us to achieve net zero. Well, we did net positive, but net zero waste in the construction industry. Construction industry produces about 40% of the whole world's waste that goes to landfill. So very, very difficult to do, but it can be done if you've got a committed professional team. Net positive waste, you can see here 5% is kind of the minimum. We've got 145% net positive waste. So we basically offset 60 tons of waste that of an entire construction project of the same size of us. Okay, part 4, what's being done? We're going to zoom down from kind of a city scale to kind of a building scale. So The city of Johannesburg that we're working with is how do we design a large-scale land sink. So we talk about land sinks in rural areas, that's pretty easy to understand. Commercial forestry, a game reserve, that will all kind of absorb carbon, but how do we do that within a city? The city of Johannesburg is relatively young, as most of us know. Originally a grassland, which most of you in Kyalami know, that kind of the original landscape is still pretty intact around these areas. And so you do have, and where it sits really specifically is within the grassland biome. So on everything north above the Michalis is savanna kind of bushveld, and everything south of the Michalis is grassland. Again, such an important, some people say that grassland actually absorbs more carbon than forests. So specifically this research project, we started to map the size of the largest man-made forest in the world, which Johannesburg is known for. We're talking about 400 square kilometers of forest and quantifying how much carbon does that actually absorb, so that the city can put that into their climate action plans. Everything in red is our critical biodiversity areas. So we're kind of in the north in Kyalami here. And those are kind of semi-intact, some of them have been transformed, but kind of protecting them as original landscapes, grassland landscapes of the city. This is some of the climate change projections for us as a city. About 2 degrees warmer, 20 millimeters less rainfall by 2050. But interestingly, the forest has created its own kind of new climate that wasn't here before. So if you had to compare Johannesburg to colder surrounding farmland, which probably Kyalami is because you're a lot more open, the forest has created a 4-degree warming compared to the surrounding areas in winter. So we can use large-scale landscaping to change climate, both from a comfort point of view and in terms of sequestering carbon. I won't bore you with all of this, but this is basically our 5-stage plan for the city. So how do you regenerate the mine dumps? The red line is our watershed line. The right-hand side is your north-flowing river systems. We've got plans for regenerating and restoring those systems. The afforestation of Soweto, so planting locally indigenous trees for that area, and then connecting the CBAs, critical biodiversity areas, with wildlife corridors through the city. So we're allowing wildlife to move across the city. And then giving guidance specifically to you as private citizens, to landscape architects about if you do have a piece of land, how do you regenerate it properly? Where do I get these species? How do I define what my vegetation type is? You guys specifically within Kyalami are within the Gorley granite grassland biome, this little pink area at the top, which is critically endangered as an ecosystem. So you can have a huge role to play with something as simple as planting some plants in your garden and landscaping space. So this is the kind of work that we're doing in terms of supporting that. All of that's using online systems that are all free to access. Again, if people are interested in that, they can speak to me afterwards. And then what we've done in terms of our pilot projects, our pilot research projects, is to choose the most difficult places in the city to intervene and develop projects that show how we do this practically. So how do we do this in Alexandra Township? How do we do this in the Braamfontein Spruit that's incredibly polluted? How do we do this in mine dumps? How do we do this in Soweto? And how do we do this in the northern suburbs of Johannesburg? So we'll go through some projects now, and I've put kind of 10 principles that aren't really aren't presented in a linear way, but are important for you to note around any kind of sustainability venture you might do in your home or in your office. So what's interesting about this project is this is done for a client in Midrand, a Swiss-based fragrance and flavor manufacturer called Munich. And we brought back the original landscaping of the site this was Igoli granite grassland, again critically endangered, and not just planting 4 or 5 different locally indigenous species. This was 135 different species, 4,000 plants, and we matched the diversity of the grassland based on what it was originally. So breaking up the grassland in terms of functional plant types, grasses, herbs, geophytes, which are just underground bulbs and other things like that, small trees, tall shrubs, low shrubs, succulents, and try to match that with as much ethically sourced planting that we could get. So there's a big myth at the time that these indigenous plants are really hard to find, they're very difficult to grow. That's just the major commercial nurseries wanting you to buy exotic species. There's no real truth in that at all. But it's not as easy as it sounds. So this is the original site, kind of a kikuyu grassland, a kikuyu lawn, which is very, very popular. It's easy to maintain, but it's kind of an invasive species from Kenya. Very difficult to get rid of if you don't want it. And this was our major kind of landscaping process of planting these plants. We did keep a memory of the Kikuyu lawn as a reminder of what the landscape was before. And then we took obviously the client was a fragrance and flavor manufacturer, so we kind of did a lot of research on the medicinal properties of locally indigenous plants, scent, are they edible or not, and try and take all this knowledge that we have in books and put it onto something that's accessible. And so we're quite proud. This is the first net positive ecology project in the country. Again, what's important about these ratings is not to use them for the rating sense, but you need to have objective certification of what you've done from a sustainability point of view to just give a sense of trust that things have been done properly. A lot of people call themselves eco-green without any kind of objective verification of those claims. All right, so let's go to a building scale, and I'm going to talk through some of the more radical projects that we've done. So we've got an R&D division that's made up of kind of the young people in our team, and generally these young people come up with crazy ideas, and we say, okay, even if it's architectural related or not, let's try and develop a solution around a very difficult problem. The housing crisis is probably the most difficult problem from an architectural point of view to solve, and the reasons for this will become pretty clear in a moment. I'm going to present two micro-housing units that were designed for informal settlement development. This one was first designed for the city of Cape Town. And these are quick assembly housing units. So you can put them up in about a week. All their technology is integrated, PV, grey water recycling. Everything can be easily maintained and used by the community. And the importance around this was instead of the one block RDP house, which really creates urban sprawl, the idea was about building up. And if you've ever been into an informal settlement, the way that the spatial system works is the outside space is actually more important than the inside space. So people have a yard space, which is this kind of communal space between units, where they'll hang their washing, they'll share a toilet, and that space actually becomes the thing that connects the community together. So if you had to just demolish the whole informal settlement and put up flats, which is government's current plan, you'd lose this kind of communal fabric that's been developed over time. So this unit specifically obviously protects that outside space and going up instead of out, and then also increases that to the pink space is on the first floor level. So increasing that space also, above just the ground floor plane. This specific unit was as cost effective as possible using corrugated iron, which is a material that we see throughout informal settlements, very, very well insulated, and it's built with local scaffolding. So the steel scaffold that you see around buildings, very, very quick assembly. It's a material that we know. That actually becomes the structural system of the building. And that gets put together very, very quickly. Second principle is to know when you use certain spaces. So in residential, you might use one room for one part of the day, you might use another room for another part of the day. Make sure that you're understanding what time of the day you're using that space so that you can design your sustainability strategy around that. So a lot of the research or maybe if you're even buying a property, you want something north-facing, because you get good light. But then you realize in residential, pre-COVID, that you spend most of your time in your house only in the evening. So we design all our buildings for the daytime, and yet for the majority of time, they actually should be operating in the evening. And that's why most of the time we design for the summer condition instead of the winter condition. And most of our houses are then extremely cold, and we have to put fireplaces and gas heaters. So this is how we do thermal performance modeling. So we'll do a model of the building. We'll put that through different climate scenarios and then understand exactly how hot or cold each room is. And passively first design in terms of insulation, correct orientation, that sort of thing first. And then if you've got everything outside the line, so this band is a comfort zone between 21 and 24 degrees. These are your different rooms, both in the summer and the winter season. And you can see in winter, even though we've done all our passive stuff, we still need some heating in winter in Cape Town. So that shows just, again, the idea around making sure that the use of space and the time you're using a space is directly related to where you need to implement technology. You're not overscaling that technology. Principle 3, connect to natural systems. So this unit was specifically inspired by us studying birds' nests, how different species built their nests in Cape Town. Specifically, they orientated it a very certain way to not get blown away by the wind. And so that's how we orientated our buildings. So this wasn't orientated from a light point of view. It was orientated to take advantage of the southeast wind, which is, if you ever lived in Cape Town, a big problem for buildings. Principle 4, convert your waste streams into resources. So we're not just talking about waste in terms of if you've got a composting system for your food waste or how you use your garden waste, but also water. So this recycles its grey water, treats that to drinking quality, and so you've got a top up in terms of your rainwater, but all these kind of waste streams that we kind of put into a pipe and not think about anymore are potential resources, specifically for you guys living in a more rural environment than the inner city. Efficiency first, I've spoken about that. I could talk about technology for days, but it's really important that not be the starting point. That we're looking at our consumption habits first and reducing those before we look at technology. But again, PV is just such an easy thing for us. We get about 1,000 watts per square, which if you think about that, that's like your microwave. That's how much energy we get from solar in South Africa. So yeah, it's a really good starting point. I'm sure most of you have, or a lot of you do have solar and PV installations. That is the way to go in terms of South Africa's renewable energy system. The firehouse was a micro-housing unit that we designed for Alexandra Township. This was about a 3-year design process, really starting from the ground up. So we did a lot of community interaction with a social facilitator. If you've ever been to Alex, basically no one really owns the land. You own your structure by police affidavit. And you build it without any professional involvement, which, as you can understand, is quite problematic. But the reason why our housing government has been trying its best to build as many houses as possible, but really hasn't made a dent in the housing crisis, and that's because the amount of people that are moving into cities are exploding. And we're getting 3 people per hour by 2025 in Johannesburg. You're getting kind of triple that in places like Kinshasa, kind of Western, Eastern Africa. A huge amount of people are moving from rural areas to urban areas, and we're just not building housing fast enough. We can't build kind of our brick and mortar 2-3 month housing project anymore. It has to be much faster. We have to build houses more like we construct vehicles. Produce a Toyota in about 18 hours. And the major problem, that was the big starting point for this design, was asking the community, what was your biggest challenge to solve? Fire being kind of the biggest terror within these environments. A lot of these fires are started again in winter because people leave their paraffin stoves on as a heating device. Again, it's actually a thermal comfort problem that you actually need to solve. And our inspiration always starts with nature first. Grasslands use fire in a way that regenerates them. Obviously, grasses are designed to burn, but yet they still come back. They still have an underground aspect that keeps them alive. And then we studied specifically plants that are adapted to fire. So half-white protea, which I'm sure many of you will be familiar with, has kind of fire-resistant bark. Its seeds are specifically only kind of germinate after a fire. And there's a whole lot of strategies around how it's adapted to kind of the high-felt cold climate that we've translated into the building itself. Where the building sits, if you've ever been to Alex, the little grey spot here is Nelson Mandela's house where he used to stay. And you can see architects call it the Nolly diagram, but the urban grain, how you had your larger houses and how that's been infilled by informal settlement, and how, I know you can look at this and be like, well, it's so unorganized, but what it has created is a wonderful thresholding of public and private space. So most in the northern suburbs, we've got our private wall, and there's kind of a strong divide between what is public and what is private. If you work in an informal settlement, you have a thresholding. So you've got a public space that's your street, that can be closed down. If the community is going to have a wedding, they close down the whole street, and the street becomes the wedding venue. You move into where cars are allowed, but it's kind of more pedestrian. That's a semi-public space. Then you get into the yard, which is, again, this negotiated space between buildings that is kind of semi-private. And obviously, when you get within the unit, it's private. So there's a wonderful transitioning of space, which makes these a lot more better from a community point of view. Informal settlements have been described more as many houses, more as kind of every room every shack is one room in a big house. And that's when people go away, that's that kind of intimacy of African culture you see in the urban grain kind of illustrated. So this project uses CLT, cross-laminated timber, which is kind of solid timber stuck together, very, very good fire rating, surprisingly, and has very, very good R values in terms of thermal comfort, and can be prefabricated and basically lifted on a crane and added to the top of a footprint. You don't have much space in these areas to build out. So that sits on an existing footprint. That's then clad with a hempcrete insulation layer, corrugated iron on the outside. Timber can't, as we know in Africa, it doesn't do well outside with our kind of PV, well, our UV rate. And then we've created kind of an ecosystem around the building. So you've got apiculture, the harvesting of honey. Stankvrucht, milk plum is a locally indigenous fruiting tree. You can make so much stuff out of it, from brandy, very high vitamin C content. Wild jasmine, indigenous form of jasmine. If you ever walked in formal settlement, it's open sewers, so it doesn't smell the greatest. So again, trying to create an ecosystem around the building, not just looking at the materials themselves. Sorry, let me go back. And then how we explain sustainability to the local community. This is a net positive carbon and net positive water unit. Net positive carbon is used to create free Wi-Fi for the customers that you can then use as a business. Net positive water, this water is using it as your irrigation system for fruiting plants and apiculture, as I've mentioned, but there's a financial incentive. So your building starts to make money for you. It's not just about saving the planet. People in these conditions are not really interested in that kind of stuff. This is what the building looks like on the inside. And again, you've got a fire protection system that protects it from fire on the outside. The Vleyhuis residential development, this is more kind of middle class to high-end housing, and really looking at from a resilience point of view. So water's still relatively cheap. There's no real payback when it comes to technology, but are we trusting the quality of the water that we're getting? Water shedding's happening now. Do we have water? That's also very, very important. So this project started again from a landscaping point of view first. We researched the original landscapes of Johannesburg, which is koppie grassland and wetland. Wetland has an interesting 2-degree cooling effect on its surrounding landscape. So if you think about that 2-degree warming for the city, this is a climate resilient way of designing your landscaping. And then again, architectural ideas about how birds build nests. How do they camouflage within a system? How they use local materials? Is there kind of intelligence that we can learn from and apply to a building scale? So this is a 5-unit development. Each unit is about 200 squares, 3-bedroom, 2 bathroom. The piece of land is about 2,500 squares. Again, energy is probably the easiest thing to get right. PV has a kind of 5 to 10 year payback at the moment if you don't need batteries. Batteries kills everything. Principle 7, understand your climate risks. So again, using the idea of landscaping as well as integrating that into the building itself. And what's nice about the landscaping in this project is that it's not just there for aesthetics. So if you're a good birder, you'll recognize some of these bird species as being endemic to in the Okavango Delta in Botswana. And we took, this was the research trip that we took to inspire our design process for the Vleyhuis. So we went to a pristine wetland. Okavango is probably one of the most incredible wetland systems in the world. Studying how does the ecological system work, how has the local community lived off the wetland for thousands of years, how do we kind of translate that into an African idea around sustainability. So the landscaping itself is the rainwater storage device. We're not putting ugly tanks. We're having a landscaping that stores our rainwater. Wetlands are natural purification systems within nature. So you've got the natural system purifying water, and then you've got a mechanical system that treats it to drinking quality. So you've got your on-site system. So the interesting thing about this is you're not wasting water down some pipe that you don't see your impact of. If you had to pollute in this water, you're polluting your own water system. So trying to link this thinking between, if you're switching on the light, are you understanding that you're burning coal? You know, that kind of thinking. If there's a slight difference in the numbers, smart people will be like, okay, Mark, why is this wetland smaller and my usage is more? This is because obviously we get a lot of rain in summer. The biggest issue with Johannesburg is we get enough rain to be off the grid from a water point of view, but you need to store that in a relatively short space of time. So over the year, that balances out. So the wetland can be slightly smaller because it does get a lot of rainwater through one major season. And then also food is critical. So one of the easiest things you can do to reduce your carbon footprint is moving towards a plant-rich diet. I still eat meat, and I'm not embarrassed about that. But plant-rich diets are the way in which you can reduce your carbon footprint. And increasing, kind of integrating food into your where you live. So we've got a rooftop farm and potential for aquaculture, which is fish farming within the wetland space itself. Again, all locally indigenous fish species, no koi or trout or anything like that. The roof space becomes an important space. So obviously you've taken a lot of the ground floor plane for this kind of natural landscape. It's a natural pool, so you can still swim in the water, but you don't really have much lawn. We've increased that kind of open space, if that's children's play area or kind of, what we love to do is outdoor braaiing with our friends and others can be created on the roof space. There's 3 cladding options. African reed, which is probably your cheapest cladding options, has a similar lifespan to thatch, kind of 10 to 20 years, but very, very cheap. So the idea around not just looking at a material that lasts forever, but perhaps a material that's cheaper, that supports local labor, that can be changed over time. That's also a very African way of looking at construction materials. Rhino wood is probably your highest spec of timber in the country. You're welcome to Google them. They're an amazing company. They've taken normal pine and impregnated that with natural wax to give the wood hardwood properties. So you can literally use this outside. FSC certified wood. And then reclaimed timber, obviously reusing timber that would have gone to landfill, using that within the building. And as I've mentioned, this got triple net zero. So net zero was never necessarily our aim and goal. Again, you've seen our research process was more about kind of uncovering what it means to be African. And the ratings came as kind of a byproduct to that. So net zero carbon, we've got operationally. Net zero water, everything is on a rainwater-based system. You've got a borehole backup if you need. Blackwater is an interesting one. We didn't deal with Blackwater on this. There was another project that I'll show you Blackwater technology on. But we're basically just connecting to the grid for sewage treatment. But grey water is recycled and treated as well. And then net positive ecology. This was obviously a brownfield exotic garden that we've brought back locally indigenous species from the Johannesburg environment. Some pretty pictures. Us as architects love these kind of pretty pictures. If you're building a new building, this is for people that want to understand how do we do that from a net zero point of view. If we want a net zero building from the first line on the page, how do we do that? Important thing is clear target setting. So if you want to do net zero, have that at the beginning or in your brief as a client. Giving that to engineers and architects just helps them structure their design processes. Remember that we get paid on the size of our building or the size of our equipment. So there's no real incentive for us to design something smaller or more efficient. So that's important. Set those targets. Understand your local weather file. I've talked about computer-based performance modeling. That's kind of the cutting edge when it comes to making sure your building is going to perform. Monitoring construction, after construction commissioning, so making sure that if you've put these air conditioners that are very expensive, making sure they are working afterwards. Understanding how people use your air conditioner, making sure there's that kind of training afterwards. Educating users on how to operate the project is really important. So again, monitoring and benchmarking those things after you've used the building. I'm going to go through 2 more projects. These are kind of at a different scale of residential, just to, again, hopefully expose you to the technologies that are out there, different materials that are out there. This is South Africa's government's first net zero carbon building, operational building, a clinic. It's a standardized design, which means that it's been tested to be built throughout the country. We had to test it in all the climate zones of South Africa, which was tricky. But really the idea of what that government is moving to is buildings that they build repeatedly, like police stations, schools, and clinics. They want a standardized design with costing so that something in Limpopo isn't costing twice as much as something built in the Eastern Cape. And also if they're replacing things like a door handle, there's not like 1,000 specs of this door handle and that door handle. So that was our design brief. We started with visiting existing clinics. I'm sure most of us are on private medical aid. Just thank the stars for that. This is a clinic in Diepsloot in Soweto. You can see very kind of, for me, oppressive. The entrance is designed for vehicles. Most people that arrive at these clinics are pedestrian orientated. They arrive by public transport, not by vehicles. This is the signage, which is incredibly confusing, unless you're a doctor, I assume. All this kind of medical jargon. This tiny little sign shows you where to go. Everything's pointing in one direction. So I'm not sure how you would find, if you're coming here if this is your first time, I don't know how you find your way. On the right-hand side, lights on during the day just shows that there's not enough natural light. Okay, super simple to design right. People sitting next to each other, a whole lot of sick people sitting next to each other, problematic. So those were some of the problems that we picked up. This is your TB line. These are your sickest people that are waiting to get treatment with no facilitation at all. So these are really difficult challenges. And COVID has really shocked architects. Healthcare design hasn't really changed in about 50 years, the kind of the philosophy around healthcare design. But in South Africa, we've been dealing with things like TB for decades. And again, things haven't changed. So This was a real big starting point for us to question the way that healthcare has been designed, and healthcare arguably is the most difficult kind of large-scale building type to get right from a sustainability point of view. Residential is probably the next most difficult. Another problem to solve, people spend about 2 to 6 hours waiting for a professional. We can't really, that's mainly due to lack of staff. We can't really change the staff aspect, but if you're going to be spending 5 hours in a waiting area, let's make sure that that waiting area is the best space you've ever been in. So this is one of the systems that we've designed, which we haven't really seen it anywhere else in the world, but it's kind of a fast tracking system. So for you to get from the street into a series of just basically simple, colorful lanes to know where to go throughout the hospital. Breaking that down into very simple to easy to understand language that will be translated into the local vernacular language of that specific area. So you've got the blue line, which is your walk-in. This is also designed for kind of if COVID had to happen again, which, pandemics are going to happen again, that you've got something that can threshold potentially infectious people before they enter the system itself and infect others. Emergency services, pretty self-explanatory. Family health, so a lot of your mothers that get vaccinations go to clinics. A lot of your chronic patients pick up medicine from these areas. So that's kind of your pink line. Spoken about medicine collection, and then chronic and preventative care, which is your gray line. This is called a bubble diagram. This is what architects use to kind of, in the very early stages, think about planning and sizing of buildings. So we've got a central waiting area and then a secondary infectious waiting area. You've got urban farming that's really trying to connect to the traditional medicine side of African healing techniques, so growing medicinal plants, trying to build a bridge between Western approaches to medicine and African approaches to medicine. There's still about 40 to 50% of South Africans that use traditional healers, so we can't ignore that. Sorry, I went too fast. And then this is a summary, again, of about 6 months of research. But the way that healthcare systems work is on the efficiency of your circulation system. So globally, nurses spend about 40% of their time walking in corridors to trying to get to the patient they're trying to serve. So if you get the circulation system right, you get the healthcare architecture right. And we did a whole study from the kind of first hospital ever designed to today. What is the most efficient circulation system? The Canadians are the best at it in the world, developed what's called the radial circulation system, most efficient. So we took that as our starting point for the architecture. We squashed that into kind of an oval shape to take advantage of north light. And then we created these large kind of roof overhangs, so overflow space for waiting areas. We have wonderful weather compared to places like Europe, so we can actually wait outside if that's necessary. So this is the plan. It's quite a simple building. So you've got the radial circulation system that's still functioning. You've got a rectilinear plan. So this is very easy to standardize. Every room is the same. Beds are the same. Doors are the same. And you've got your pre-entry triage system with your different colors. On the north, you've got an infectious waiting area. You've got your central waiting area. These are kind of your benches that make kind of a communal community library space. You've got a children's play area, and yeah, I won't bore you with the rest. If people are interested in this, welcome to chat about it. But this was kind of an endpoint of professors from universities all over the world, people that work in clinics, obviously local and provincial government we worked with to get to this plan. In section, TB transmission, 8% of all people that get TB get it from going to the clinic. So this had to be solved. And this is really about how to control airflow, making sure that you're not getting air mixing across different spaces. So your waiting areas are generally your most infectious or high-risk spaces because people don't know that they have TB. So making sure that that's basically naturally ventilated. It's basically it's outside with a roof above it. And then what's interesting above that waiting area is we have a transparent PV roof system. So you can get PV panels now that allow light through them. And this was part of us solving the problem of theft. PV theft in rural areas is massive. So this is basically a PV panel within a plastic membrane, so about 1 or 2 millimeters thick, that you stick onto a piece of glass. So to steal it, you'd have to break the glass and therefore break the PV. So that means that this material, in its construction process, is locking away more carbon than it's producing in its manufacturing. Cement is seen as kind of the devil of sustainability, but now you can see how you can combine kind of traditional materials in a new way. What's important about this is you still have a high labor intensity. So something like CLT that I showed before, all prefabricated in a factory, put together kind of very, very easily, but kind of we destroy our labor need in the construction industry. This is still very important for us to be able to upskill people with 40% unemployment. We can't ignore the opportunity the construction industry has to upskill people. This is some of our performance modeling. If you're interested, there might be some technical people that are interested in this, but this is us testing the building in each of the most extreme climate zones throughout the country, the hottest, the coldest, the most humid, making sure the building is performing within that. And then what you do with this is kind of the energy budget of most of the systems. In large-scale buildings, most of your energy is used in your air conditioning system. In residential, most of your energy is generally in hot water heating. So you always start there and make sure that the building is obviously as efficient as possible in terms of the fabric that you're using, insulation, other things, getting natural light. And then, again, net zero, meaning that this is your consumption. Everything is balanced with a renewable energy system like, in this case, PV. And this is what the building looks like. We've integrated kind of, again, traditional medicine and local creeping plants on the facade into the fence line. This is the inside of the building. This is your monster rainwater gutter. Again, basically the roof slopes inwards like that aloe. It kind of absorbs as much water as it can. So it can be independent depending on where you place it in the country in terms of water. This is your transparent PV system. You've got your seating, which this main waiting area is designed for conversation. It's integrated with a community library. And again, so you're seeing a mix of these things. I could talk a little bit about black water. We did extensive studies into black water treatment. There's so many technologies at the moment that even some of them are South African invented in terms of treating black water. So there's a way to be able to do that even on a residential scale now. And the inside of the building is pretty conventional. And then cost. This is probably the major thing that we get from clients. How much is it going to cost? Why is it so much more expensive? How much more expensive is it? So this is what we produced. This is the conventional structure. If you had to build it today out of normal brick and mortar, this is how much this project would cost you. And the net zero, you can see, is adding, this is obviously just looking at materials that change. So you're probably adding between a 10 and 20% increase in cost, capital cost. But what's important is that this specific building uses its energy mainly during the day, so it doesn't have the issues of batteries and pay off of batteries. Because it's being used during the day, it pays it off in about 5 years. And then obviously every aspect after that, it's actually earning you money because you're not obviously paying Eskom. So this was a big shift towards argument to government around producing buildings based on their life cycle cost instead of just their capital cost. And this is my last project. This is a bit wild, so it might be a little bit different for most of you. But the last principle is about dreaming big and dreaming long. So if you think about your most favorite building, if you think about what comes to mind, a lot of people, it's kind of Gothic, maybe Gothic cathedrals in Europe. A lot of people don't know those buildings took like 100 years to build. There was a vision in terms of the professional team around that actually handed over to another generation and continued that kind of work. Where today we try to build buildings as cheaply and as quickly as possible. We sometimes need projects that are 200 years long, and this is one of them. So African elephants, if you're not familiar, are an endangered species. In South Africa, we actually have an overpopulation of them, and so we have to, in Kruger they cull, in Addo they use contraception, but they're kind of quite a problematic animal in South Africa. And that's because they're designed to migrate as a species. They're not designed to be kept in fenced conservation areas. And so electric fences in themselves are not enough to be able to control elephant movement. So this came out of our R&D division with our young people asking some crazy questions. How do we solve elephant conservation? This is a 1,000-kilometer migration route that we've designed for elephants to move across game reserves that already have them. So things like Madikwe, you can see the Pilansberg, the Mchalis, you can see Kruger. So what would it mean for us to design kind of a wildlife corridor at this kind of scale? What would it mean for rural areas? You can see the migration route goes quite close to Tshwane. What would that mean for cities? Let's have a bigger vision than just looking at buildings. So this is where the proof of concept site is within Limpopo. If you're familiar with Limpopo, it's right next to Mabula Game Reserve. So you can see the major provincial route is this big area. We've zoomed in to start with private landowners and basically them being able to allow elephants to move temporarily through their land as they migrate. What would that look like? And you can see that kind of approach opens up a whole lot of smaller land parcels that don't really have much function. If you don't have the big five, it's very difficult to kind of attract tourism and kind of upbuild these areas, even though they're very important from a biodiversity point of view. So these are the landowners that we're dealing with. The blue are landowners that are signed onto the program. The little red dots are one of our pieces of technology, which is an AI-driven elephant gate that uses AI camera technology to identify what an elephant looks like and opens a gate through a fence line for them and them alone. So you can have things like cattle, other dangerous game on your piece of land as a landowner, and problematic, not kind of losing that aspect of your commercial venture. And then we've worked with musicians. Elephants communicate through infrasound, which is about 20 hertz and lower. We probably hear to about 20 hertz. And we've just started to understand how complex their language is. So there was probably infrasound in elephants were probably discovered about 1960s. We now know that there's different dialects across Africa. They can understand male and female. They can identify if something's on, like a female's on heat or not. They can identify if they know you or not. So we have a musician that did his master's in elephant acoustics, designed an elephant language to be able to communicate to these animals, to teach them how to use the system. So what you're seeing here in these circles is our infrasonic speaker system projecting to about 2 kilometers. Elephants here to about 4 kilometers. So this is really where the project has come from. So you've got two technologies, what we've called a sounding tower that generates the sound, teaches the elephant how to use the system, and this automatic elephant gate. And the idea around this is to rebrand the elephant from kind of a Western tourism thing, come see the pretty elephant, to a community asset. So elephants are endangered because they're getting killed for their ivory and killed because they're a fantastic source of meat. Think how much meat gets generated from elephant. We have to rebrand the elephant from an African point of view. How can it create rural community value? The elephant's ecological role is a seed dispersal agent. It eats fruit. Its dung kind of plants those trees, and over time those trees grow. This is the marula, which we all know. But it's a fantastic staple food. So throughout Africa, it's used as a staple food. Seed super high in in protein content, high vitamin C content than oranges. Amazing plant, and it grows very, very quickly. So the idea with this route would be elephants are fed these kind of locally indigenous fruiting trees. In the first year, a lot of this land is degraded in rural areas. They used to remove invasive species, fed these trees. These trees are obviously planted. Things like marula grow at about 1.5 meters per year. So you're talking about a significant tree growth even within the first 5 years. Within the first 10 years, you've got a self-sustaining food forest that's gardened by elephants. So elephants are seen as an asset towards sustaining a food system rather than just a way to make money. And the excitement around this and the work I'm doing with the University of Cambridge is that you can certify the carbon credit impact of an elephant over its lifespan. And put a monetary value to that. So there's huge excitement in funding this project through the EU and other funding mechanisms as we protect the species over its lifespan. And obviously what I'm interested in is what does that mean for the city? So what happens if this route had to move through Johannesburg? How would the city have to change? How would the concept of who's the citizen of the city have to change if we increase our citizen base to be the elephant? Infrasonics, if you're not familiar, this is just a spectrograph of an elephant call. So everything below 20 hertz, which is that line, is all this kind of information that we don't really understand yet about how complex elephant communication is. Our elephant acoustic expert, Franco Schumann, this is him mapping everything that uses low-frequency calling in this area. So we didn't want to affect ground hornbills or frogs or anything that uses low-frequency calls, and designing this kind of elephant language. And then from a biomimetic point of view, the system itself has got a lot of electronics that has to be protected from lightning. So we designed a Faraday cage made out of aluminium inspired by the way that elephant skin is designed to crack. So elephants don't sweat. At a kind of very micro structure level, their skin cracks and they fill that with mud and dust. And that's what, through evaporative cooling, that's what cools them. The Asian elephant doesn't have this, for example. That's been translated into a microstructure that we've translated into aluminium skin that basically cools the electronic equipment of the sounding tower. So all off the grid, it's got a PV system. You've got camera for our CCTV AI system technology. That AI software we borrowed from the security industry. We literally had to train the program like this is what an elephant looks like. Then you've got the bottom is made out of biomass insulated concrete. We naively thought that the speaker for infrasound needs to be placed higher. Infrasound actually uses the ground to kind of crawl. So when lightning strikes and your building vibrates, that's infrasound. That's vibrating that. Very, very large wavelength. So all your equipment in terms of your speaker, your battery system is in that kind of concrete box. And then you've got your automatic gate system that opens. So our professional team implementing the first proof of concept on site, very, very diverse. Our skill as architects is really to bring these really diverse professionals together, give them some kind of leadership and guidance, and really just point them in the right direction. But you've got elephant behavioralists, conservationists, ecologists, all the spectrum of your engineering disciplines. This is our crazy German speaker manufacturer. He invented an infrasonic speaker. Obviously, most speakers are designed for human hearing. They're not designed for playing sound that humans can't hear, so he invented an infrasound speaker for us. Some of the tech. This is our infrasound speaker. Very, very strange standing in front of this because you can't hear the sound, but you can feel it moving through your body. Vibrates the water in your body. It's a strange experience. And this was quite a big moment for us in terms of being able to identify what an elephant looks like, using AI technology for a sounding call to call them to move through a gate and for that gate to close. Sounds simple, but kind of 2 years of research to get us to this point. So this happened beginning of last year. And then this is my last slide. So this is just talking about, again, an African view of sustainability. James Suzman was an anthropologist who lived with the sand for about 20 years, and he wrote a book called Affluence Without Abundance. And he argues that the most successful civilization in the world is the one that could sustain their civilization over the longest period of time. And if that's the metric that we use for success, then the San are the most successful civilization to have ever lived, sustained their culture for 50,000 years. This is the San's worldview. So everything's structured around water, semi-nomadic. They've got their hunting ground, which they get all their medicine and food from. They live off a plant-rich diet of about 130 plant species. They do have meat, but meat was rare. Their camp, net zero carbon, fully biodegradable. There's no waste. You don't see any net zero waste. Waste wasn't even an idea in San thinking. And then they've got these two spiritual dimensions. One is the sky. I've just superimposed personal dreams onto that. And one is the underworld, which I've superimposed governing authority. So again, Africans, in terms of our carbon footprint, we are really the most sustainable continent in the world. We have obviously massive issues when it comes to development. Most of the new cities in the world are going to be built in Africa in the next 20 years. So we have an opportunity to develop in a way that leads the West, not just about technology, but in a way that shows them what it means to be African. And for me, Africans are sustainable in their culture already. So thank you very much for your time.